Alright, our next topic is equations. So this is just a very basic introduction. We're not even going to be solving them really. We're just going to kind of be understanding what is an equation, what are the vocabulary words associated with equations so that we can talk about them and know what everyone's talking about. So the first vocab word is just what is an equation. An equation is any expression on the left with an equal sign and another expression on the right. So you've got stuff here, something, equal, and then some more stuff. And what is this stuff on the left and the right? It could be pretty much anything. The more complicated it is, the harder the math is going to be. So in the level that we're dealing with, the algebra that we'll be having might be something like 3x plus 5 equals x minus 7, something like that. So you've got some expression here and some expression here, and they are supposedly equal to each other, and this makes an equation. The solution to an equation is a value for the variable that makes the equation true. So there is some particular value of x, which if we plug it in, it'll actually make this true. The numerical value on this side will be equal to the numerical value on this side. For other values of x that are not the solution, this will actually be not true or false. So when you're looking for a solution, you're trying to find the value of x which makes the equation true, which makes the left side actually equal to the right side. Okay, what is a set? A set is just a collection of objects or numbers. Okay, and it's shown in brackets typically. The reason this has something to do with math is because you can have a solution set. Sometimes there's more than one answer, and so if you have 2 or 3 or 4 answers, you call that a solution set. So that's our next vocabulary word, solution set. The set of all possible solutions. Oftentimes, especially in Algebra 1, you'll only have one solution. So it seems weird to call it a set of solutions when there's only one. But we'll have some different examples. Absolute values are one example, and parabolas or quadratic equations are another example where you'll have more than one answer for a given problem. And so we would call that the solution set. Okay? Another simple vocabulary word is the element. The element is the name of one object in a set. So if you have 2 or 3 solutions, each one of them is one element in the solution set. As I'm saying this, I find it, maybe as a student, this is kind of annoying to have all these different vocabulary words. I can assure you that these are not going to play a very large role. So if you're a little unsure of how you're going to use these words, don't worry too much. And anytime I use these words in class, always feel free to stop me and say, hey, what does that mean again? Okay, 2 more. An identity equation. This is an equation that's true for all values of the variable. So we had just said that an equation typically is only true for a certain value of x, namely the solution. But sometimes you have an equation that's always true. For example, 3x equals 3x. Well, it doesn't matter what value of x I pick. This equation is always true. So this is called an identity equation. It's when the left side is exactly identical to the right side. They are always true regardless of what value you choose. So the solution set is all numbers, all real numbers. And this is a fancy symbol right here that means all real numbers. So all possible numbers are solutions. Another possibility is that you have no solutions. So this is a possible answer. It doesn't mean that there is an answer. It means that the answer you will give to your teacher or on a quiz or a test is that there is no solution. There is no answer. So for example, if I said 3x equals 4x, well, that's actually true. That has a solution. When is that true? That's true when x equals 0. Okay, so this has a solution. But what if I said 5 equals 2? This one has no solution. So typically your problem will start off a lot more complicated. You'll do some solving and you'll do a whole bunch of work and you'll arrive at the end at something that doesn't make any sense like this. And what that's basically telling you is the only way your original problem would be able to be solved is if 5 equals 2. But since 5 doesn't equal 2, you know that that original problem could not be solved, and therefore the original problem has no solution. So this is more of like a bit of information that the problem gives you at the end that tells you that it had no solution. Okay? So first let's check if numbers are solutions. How do you check? All you have to do to check if something is a solution is plug it in and see if it works. So is x equals 5 a solution to 3x to the second power, or 3x squared, plus x equals 80? So we plug x equals 5 in right here. Now let's remember our order of operations. 3 times 5 squared plus 5 equals 80. Let's simplify this left-hand side. I'm going to do my exponent first. 5 squared is 25, and 25 times 3 is 75. Okay, 75 plus 5 equals 80. So yes, x equals 5 is a solution of this equation. If I tried other values, like x equals 4, 3, or 7, they'd probably not work. Maybe they would. There might be more than one that works. But in general, if you just pick a number at random, it's probably not going to be a solution. Okay, let's do another one. Is y equals negative 2, a solution to 6y minus 1 equals 2y plus 3. So we'll plug it in, substitute this in. Negative 2, 6 times negative 2 right here. 6 times negative 2 is negative 12 minus 1 equals, now plug negative 2 in right here, and we get negative 4 plus 3. So check this side, negative 12 minus 1 is negative 13. Check this side, negative 4 plus 3 is negative 1. So no, this is not a solution because we arrived at something which is not true, right? So if you arrive at something which is not true, then your answer is no solution. So, hope I'm not going too quickly, but remember that with these videos, the great thing is you can always pause them and try to solve the problems yourself if you want to, or just look at them and think, what would I do? And then resume and see if what you did is the same as what I did. Again, you need to be taking notes and copying down all the vocabulary words, and later on problem-solving tips, but you don't actually have to copy down these examples, although you're welcome to if you want to. Alright, a couple more examples. Solving very basic equations. So remember, you can plug back your answer to verify and make sure you're right. So anytime you're solving an equation, it's nice because you can pretty much guarantee that you're right by plugging your answer back in. So here we go. X plus 4 equals 8. Some number plus 4 is 8. So you might be able to just look at it and know what it is. But there's a special technique that we use, and it's called undoing or working backwards. So right now we have a certain unknown number x, and we've added 4 to it. If we want to think back to what it was before, we have to do the opposite, which is minus 4. And so there's a very particular, nice, organized way to show your work, which is to do the opposite of whatever's happening. So the opposite of plus 4 is minus 4. Those cancel out. So on the left-hand side of the equation, we just have an x. On the right-hand side, we have 8 minus 4, which is 4. And of course, if you add 4 plus 4, you get 8. So it's very easy, but I just want to show that idea, that method of solving is by working backwards, by undoing or doing the opposite of whatever you see. So in example number 4, what do we see? Our number x has been multiplied by 5. So the opposite is to divide by 5 or multiply by 1/5. And if we do the left side, we also do the right-hand side. We'll talk about the golden rule and solving equations a whole bunch more coming up, but this is just a very, very basic introduction, hopefully something you've already seen before. On this side, 5 divided by 5 cancels out. So we get our solution, x equals 20 divided by 5, which is 4. And of course, if you plug this back in, 5 times 4 is 20. So these simple equations are easy to check your answers and kind of easy to visualize or see, but it's extremely important that you start off by building good habits, because as the problem gets harder and harder, you don't want to be in the bad habit situation and then not know what to do. So I will really emphasize this year following procedures and building good habits. That way, when you get to the hard problems, they won't seem so hard after all. Alright, that's it.